All right, hello. So today we're going to be working more on proving triangles and then also using CPCTC. The corresponding parts of congruent triangles are congruent to each other. So here we go. First of all, reminder of what does the definition of congruent triangles mean? Definition of congruent triangles means that if you have congruent triangles, all the corresponding parts will be congruent to each other, all the corresponding sides and angles. The next thing is my cat is deciding to play with the groceries I just purchased. She's patting them down next to me. All right, here we go. So the thing is that we did this yesterday in our notes. We talked about, hey, if you've proven that two triangles are congruent, or they even tell you that two triangles are congruent, we're allowed to state that their parts will match. Okay, we're like, oh yeah, we know these guys are congruent. Well, then, therefore, you could say, oh, that means that angle F and angle C must be congruent as well. By corresponding parts of congruent triangles will be congruent. So this is just a reenactment of some of the proofs we did yesterday. Okay, so the new part today would be, can we just get a little bit more practice? Can we do just a couple more questions that will help us think about them more fluently and just get a little better? Okay, so here we go. So I'm going to get my colors situated for myself right this second. So I'd like a nice purple, and I've got a good blue here. Let's get that going. How about nice? Not working out for me. Okay. And here we go. How about one more color for us? Okay, done. Okay, so the reminder also is we have multiple ways to prove that triangles are congruent. The first thing we learned was, pardon me, that if we prove that all the sides and angles of the triangle are congruent, we can show that they are congruent triangles. Okay, this is definitely the most wearying way, and at times we'll ask you to do it just because it's a good, good stretch. Okay, a good workout. But it is one option. The shorter methods are as follows. You can do side angle side congruence postulate. You can do side angle side congruence postulate. You can do angle side angle, angle side, and then you can also do hypotenuse leg. Okay, so hypotenuse leg is a bit of a take on, you can't do the naughty one, angle side side. However, if your angle is right, then you know that if you know the hypotenuse leg, the triangles will be congruent. Okay, so you first say, hey, we've got right triangles, by saying, and then you say, okay, you show that the hypotenuse leg are congruent, and then you say, therefore they're congruent. So our practice warm-up would be, hey, will these triangles be congruent? Yes or no? Okay, and so here we go. I spy a side and I spy an angle. Okay, the next thing I spy is a common side here. Okay, so if you got a common side, okay, then you can call it to be congruent. Okay, but the problem is it spells angle side side, but it doesn't. Okay, it also spells hypotenuse leg. So this would be a yes by hypotenuse leg. That's a yes. Okay. The next one says, I spy, pardon me, an angle and another, an angle. And I also see, pardon me, a side. Okay. Is there anything else you see? Well, I spy vertical angles who match up. So let's write down these two vertical angles who match up. So it looks like we have a common angle and then another angle and then a side. So in the order it goes is angle, angle, side. And that would be a yes. Okay, so we've got plenty to prove. This is three angles. That only proves that they're similar. If we don't know a corresponding side as well, three angles only shows that they are similar in shape. Okay, so if you had a Barbie doll that was made after you, all your angles have to match. Otherwise, you won't be very similar to each other. If none of your sides, if your sides are just proportional to each other, you're not going to be congruent. You'll just be similar. Okay, so these may be congruent, but unless you know the length of one side corresponds with another side and that they're congruent, you don't know for sure that they are going to be congruent triangles. So this would be angle, 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 and this would be no. Okay, let's go back here. Angle, 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 because you only know 3 angles, that's a no. Okay, they're similar, not congruent. The word for similar is a little this, okay? So just heads up, you should actually write the word, but that's what that is. Okay, next one. I know an angle, then a side, then an angle. Well, that would be a yes by angle, side, angle. Okay, so let's do a proof, okay? Here we go. Let's write down what we know. We know that QR and SR are going to be congruent to each other. So QR, I'm going to use a highlighter to show that. So QR and SR are going to be congruent. Okay, that's going to be given. We also know, let's just want a given here. So we know side. We also know that RT bisects segment QS. So where's QS? Well, QS is right here. So if it bisects it, well, then something gets chopped in half. There are 2 pieces that match. So it's a segment that gets chopped in half. So the 2 segments will be congruent. So now they're going to go through a little bit longer thing here. This bisects it. Technically, you could just say, hi, it bisects it. And so therefore, those 2 segments are going to be congruent. Okay, definition. That would be definition of a segment bisector. Okay, now they're going to go a little bit more formal, and so we're going to follow it because guess what? They're running the proof. We're just filling in the missing parts. So T is that if you have a bisector, that means there is a midpoint. So they're going to just draw it out and be as formal as they can make it. So like, oh, there's a midpoint here. Okay, cool. By definition of a midpoint. Okay, so if something gets bisected, a midpoint can bisect things. Okay, so could a segment, so could be a ray. So they're like, all right, we got a midpoint there. Okay, so and then we can say, okay, those 2 segments are congruent by the midpoint theorem. So they're just going a little bit different route. We're just going to follow their lead. No big deal. It's like dancing. You just got to kind of follow your lead of your partner. So QT is going to be congruent to TS. Okay. By the midpoint theorem. So we have 2 segments that are congruent. So that's a segment. Okay. We also are given that those blue segments are congruent. So that would be another segment. Okay. And then look at this. They're telling us that TR is congruent to itself. Okay. Well, there you go. We got these 2 segments are congruent to each other. And there's that common segment in the middle. Okay, so we're going to say that middle segment is going to be congruent to itself by the reflexive property, okay, of congruence. So let's do it by the reflexive property of congruence. Hey, we got this. So how do we know the 2 triangles are congruent? Well, we know the 2 triangles are congruent by side, side, side congruency theorem, okay? And so, and actually it's a postulate, sorry. Side, 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 congruence postulate. Okay, here we go. It doesn't need to be proven. So QRT is going to be congruent to triangle SRT. And that's by the side, 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 congruence, and that's a postulate. There you go. All right, well, that was good. Let's look at the next proof we've got. We don't have that many proofs today because I want us to have time in class to work on some of our homework together. Okay, here we go. All right, so here's a good old proof. Let's see if we can kind of see what we know. Okay, so the first thing we know is that MO and NP bisect each other. Okay, so they chop each other in half. It's like throwing 2 sharp knives into a drawer. They chop each other in half. Okay, so that means that the length of these 2 segments are going to be congruent to each other. Okay. And then also we know that, here we go. If this one gets bisected by the pink segment, well, then you know that also these 2 segments are going to be congruent to each other as well. So like, I'll put these, okay, there you go. These 2 match these 2. Okay, so let's see. Oh, I think they're going to take the long route again. Okay, fine. They bisect each other given. X is the midpoint. Okay, definition of a midpoint. Okay, so again, a midpoint can bisect 2 things. 2 segments can bisect each other. 2, like a ray can bisect something. So There we go. Now we know that the parts are matching. So they're saying those two pink parts and those two purple parts are congruent by the midpoint theorem. Okay. Now, if we know two corresponding sides match, okay, we need either a third side or another angle. Okay, so either an angle in between them or we need to have another side. I'm out of givens. Okay, all they gave us is that they bisect each other. So we're like, awesome. Okay, so what we're going to do then is we're going to pull a vertical angle out of our hat. Okay, do you see that these two angles are going to be vertical to each other? Okay, and so our hope is to prove that MN is parallel to OP. Okay, so that means if the triangles are congruent, then we can go work backwards and say, hey, then that means that there's some angles that match. And if the angles match that are alternate interior, then we know the lines have to be parallel. So that's kind of our overall plan. First, prove those two triangles match. Then we're going to show that the alternate interior angles are congruent. So then, therefore, the two lines have to be parallel to each other. Okay, so let's do this. So if the first one says MXN and OXP are going to be vertical angles, by definition of vertical angles. Okay, and then we say, okay, that means they're congruent by the vertical angles theorem. Okay, so we have those angles. So we have two sides and an angle included between them. So we know those two triangles are congruent to each other. Okay, so sometimes the goal is to prove triangles are congruent. Sometimes that's kind of one of the steps, is to show that the triangles are congruent, and then you state that somebody else is congruent as well from those two triangles. We're going to go even a step kind of diagonal from there to be like, okay, well, if those two triangles are congruent by the side angle side, okay, side angle side, congruency postulate, okay. Okay, then we know that we want to show these two lines are parallel, so we've got to find some alternate interior angles that are going to help us along the way. Okay, so here we go. I'm going to look at, what if we grab, okay, so we need some alternate interior angles. We could there's several options, but they're asking us to do angle 1 and 2. So we're going to follow their lead, okay? And so let's look at angle 1, okay, and angle 2. Okay, those are up here and here, okay? And so because we've proven that those two triangles are congruent, we do know that angle 1 and 2 are congruent by CPCTC. So then we're going to say, okay, they must be congruent. And we also know that those are alternate interior by definition of alternate interior. And so if you've got alternate interior angles who are congruent, then that means that the lines have to be parallel. Okay, so therefore, that's what those three dots mean, is therefore the lines are parallel by the converse of alternate interior angles theorem. Okay, so remember the regular theorem says if you have parallel lines and alternate interior angles, they have to be congruent. Well, if you have alternate interior angles who are congruent, then that means the lines have to be parallel to each other. Okay, all right, so we've got two proofs to do. Okay, the first one is going to be as shown. So let's see what we can come up with here. Okay, okay. We've got triangle DEA is congruent. Wait a minute. So they're giving us that two triangles are congruent to each other. Okay, so that means they didn't just give us that they're congruent. They gave us 6 facts that we could use as we choose, willy-nilly. Okay, so we know that DEA, okay, that's right here, the whole triangle, all her corresponding parts are going to match with SEB. Okay, CEB over here. You're like, use it as you need to here. Okay, got a whole toolkit going on over there. Okay, and then they also said, in addition, as if that wasn't enough, DAB and CBA are going to also be congruent. Okay, so let's see where DAB and CBA are. So DAB is right here. It's going to be congruent to CBA. So that's CBA right here. Okay, and those are both given. It kind of looks like I made a right angle. I just not drawing very well with my marker. Okay. And so our hope is to prove that DAB and CBA's triangles, okay, DAB, okay, I'm going to get a highlighter up for this one. I want to show, we want to say, let's prove that this triangle right here is going to be congruent to the other one that's across from it, okay? And so, so we need to have enough parts, okay? So I think the big thing is, if looking at this, I think we're going to be okay. Okay, given that those original triangles are congruent to each other. Okay, and then also that those angles are congruent. Okay, can we prove that those bigger triangles will match each other? Okay, well, I see a common side. Okay, AB is congruent to itself. Okay, and that's in two of those bigger triangles. So let's use it. AB is congruent to herself. Why? Reflexive property. Okay, the next thing I would say is we've got, from our original statement, remember those purple triangles that are congruent? So let me erase a little bit and we can look at this. Okay, so we've got, if I get rid of this, kind of our goal is to show this, we have these triangles that are actually congruent to each other. Okay, so we know she matches her. Okay, and so if those two triangles match, we've got 6 different things that are true, but who will help us? Okay, I believe that the thing will help us is that this side right here is congruent to that side there. What do you mean, woman? Well, look, if this side right here matches this side right here, well, then we have this side right here, an angle, and this side right here. So we've got SAS to be able to prove the 2 triangles are congruent. Okay, so look at that as much as you need to, but I'm going to say AD is congruent to BC. Why? Corresponding parts of congruent triangles are congruent from this step right here, okay? From this triangle, okay? If those 2 purple triangles are congruent, their parts match. So therefore, we have side angle side, okay? Congruency, okay? Postulate to show, well, guess what? The 2 triangles they asked us to prove are also congruent as well. So we were given one set of triangles, and that's kind of like a blank check, okay? And you're like, I got 6 things I could use. Which one should I use? Well, you've got to look and say which one would make sense. And in this case, showing that these 2 sides right here will be congruent, okay, is going to be what we only need. They gave us that angle that was pink, A and B. We can do the reflexive property to say that AB is congruent to itself, and then we can just choose one side, which is AB, AD, and BC. Okay, look at us, rolling. Okay, the next one is going to be, our last one is going to be given that AB and DE are congruent. Okay, AB, okay, it's already marked. Okay, so I'm going to get out a color and we can kind of see it. So AB and ED are congruent to each other. Okay, and that's given. And then also we have that AC is congruent to DAF. I did intend to make it a different color, so I'll try to go over it a little bit. Here we go. These 2 are congruent as well. And both of those are in the first step that's given. Okay, so we've got 2 sides. Okay, side and a side. Okay, now they are talking about somebody being parallel. Okay, AB is parallel, okay, to ED. Okay, all right. Well, parallel means normally alternate interior. Okay, so what triangle, we're trying to prove that B and E are congruent to each other, angle B and angle E. Okay, and so I think the big thing is we're going to show that these 2 triangles that are written are going to be congruent. We know 2 sides. Let's just get the angle in between here. Do you see that the angle right here and this angle right here are going to be alternate interior angles? Actually, they are going to be alternate exterior angles, aren't they? And so those are alternate exterior angles between those parallel lines. Okay, so let's do it. So AB is, that's given, okay? Okay, and so angle CAB and angle EDF are going to be alternate exterior by definition of alternate exterior. That does not look like that word, but there you go. And then also, as a result, angle CAB will be congruent to angle EDF. Okay, so if two lines are parallel and they have a transversal connecting them, okay, there are all sorts of relationships. Normally it's going to be alternate exterior, but this is alternate exterior. And so alternate exterior angles theorem. And then, so we have an angle, so we have side angle, side. So therefore, we can say, okay, triangle CAB is going to be congruent to triangle FDE, and then by side angle side, two sides that they gave us and one angle that we grabbed, because parallel lines mean there's a lot of relationships, mostly alternate interior, but this is alternate exterior. And as a result, their parts match. So angle B has to be congruent to angle E. Why? Corresponding parts of congruent triangles have to be congruent. All right. Well, good job. We had a good day.